I used to think tweaking M365 settings was the answer to every slow Teams call until I watched our network diagrams and realized that culprit isn't in Redmond, it's lurking in my own firewall. If you've patched, optimized, and toggled every policy but users still complain, it's time for a behind-the-scenes look at what really drives cloud performance, your physical and virtual network. Ready to find the real bottleneck? Why the blame is misplaced, unmasking the real bottleneck. If you manage M365 in just about any organization, you know the drill. Monday morning and the help desk lines start lighting up. Teams kept dropping my call. SharePoint took ages to open that document. Is Microsoft down again? It's almost a ritual. Users send those tickets, admins scramble to check the health dashboard, Exchange barely blips, and everything looks green. So naturally, the next step is tweaking every policy you can think of. Maybe shave down those retention rules, tinker with conditional access, check for old add-ins, even reboot half your servers just in case. And after all that, your users swear it's still taking 10 seconds to open PowerPoint files. It's enough to make you start doubting the whole M365 stack. Here's where it gets interesting, because the real problem usually kicks in long before your data even hits those Microsoft servers. It's a tough pill to swallow. We've all pointed the finger at M365 itself when performance crawls, but the data rarely lines up with that story. Microsoft's entire cloud architecture is built for scale. Their core services are redundant across regions, sitting behind walls of global CDNs, and have enterprise-grade failovers. The boring truth is Microsoft's backbone is almost never the problem. Most of that lag people complain about doesn't trace back to Redmond at all. It gets lost somewhere inside your own network rack, miles from any Azure data center. There's a reason IT pros keep looping back on the same issues. Picture a Teams meeting going off the rails. Voices start cutting in and out. Screen shares look like PowerPoint from 1999. And someone asks in the chat, is Microsoft having problems? You run your checks. Microsoft 365 Service Health green. Your infrastructure patrolled by more monitoring dashboards than anyone knows what to do with. Still, the call lags, and everyone's sure Microsoft is at fault. Except the real culprit is probably closer than anyone suspects. More often than not, the data never even gets a clean shot at the cloud because it's busy tripping over a badly configured local gateway, overworked proxy, or a well-meaning firewall rule that's years out of date. Let's throw in some real-world perspective. There's a healthcare company that spent months battling user complaints about slow SharePoint syncs and flaky Teams meetings. New laptops didn't help, nor did swapping out Wi-Fi gear or rolling out even more monitoring tools. The breakthrough came from a random network admin who traced the M365 traffic logs straight to a single firewall rule, a leftover setting forcing every bit of Microsoft Cloud data through 4 layers of packet inspection and deep scanning. One simple change: allow trusted M365 endpoints to pass through with minimal inspection. By the next morning, not only was SharePoint flying, but even Microsoft Teams calls felt smoother than anyone remembered, all without raising a single Microsoft support case. That's not a one-off scenario. Microsoft's own telemetry shows the vast majority of performance issues arise before their infrastructure even gets involved. One long-running analysis of M365 network incidents flagged just how often the problem is really a homegrown policy, a routing misfire, or an aging VPN configuration that survived 3 IT directors. The official guidance is blunt. Prioritize local egress for M365 traffic and avoid hairpinning your data back to the mothership if you want reliable performance. Cloud architects have been repeating it for years, but inside the average organization, legacy controls and old behaviors keep slowing everyone down. Some of the research from Microsoft's Global Cloud Networking Group puts it plainly. Users see the best performance when traffic travels the shortest possible route, straight from the client, out the nearest egress point, and directly to Microsoft's backbone. Anything else creates hops, delays, and unnecessary points of failure. If your security stack or proxy inserts extra authentication challenges or tries to decrypt every packet, expect Teams and SharePoint to protest in slow motion. Tracing these bottlenecks isn't just an exercise in blaming the firewall, it's usually the low-hanging fruit that IT teams overlook because they're sure the network is locked down and fine. These invisible tripwires cause daily chaos. The kicker is that so many organizations treat M365 like an on-premises workload, locking it behind the same choke points they built for the 2010 era. Meanwhile, Microsoft has engineered their stack for direct, modern internet connectivity, hoping you'll trust their perimeter as much as your own. The result? Endless cycles of troubleshooting where admins try every M365 tweak in the book, but miss the obvious. Until you fix the network path, you're just applying bandages. So if every support call and monitoring dashboard still points at the cloud, it's time to look closer to home. Ignore these network tweaks and you'll waste time chasing digital ghosts. Catch them early and you'll see the kind of overnight improvement that takes user complaints from a daily occurrence to an occasional memory. The logical question now, what are the specific network mistakes that keep tripping everyone up? That's where things get revealing. 3 routing mistakes that ruin cloud performance. It's easy to look at your network diagrams and see clean lines, all those labeled firewalls, the tidy proxies, the connections you drew with a few clicks in Visio. But the truth is, many IT teams don't actually watch what their own infrastructure does to M365 traffic once it leaves a user's device. If you haven't scrutinized your actual packet flow lately, you might assume things are fine. The firewall's doing its job, the proxy's humming along, and we've run the same setup for years. That kind of autopilot confidence is usually the first warning sign, because baked deep into most environments are a few destined to slow down M365 mistakes that everyone assumes keep them safer or make management easier. Let's start with the most classic offender. The central firewall or proxy choke point, you know the model. Every packet, including Teams calls, SharePoint syncs, and file uploads, makes a round trip to HQ or some overloaded regional hub before it ever meets the open internet. It sounds secure, one place to control and monitor everything. It also sounds manageable because centralized rules are easier to audit. But the impact on Microsoft 365 is a bit like forcing all traffic to stop at a toll booth in rush hour. You see bottlenecks, stacking latency as your packets line up to be inspected and scanned. Microsoft engineered their endpoints and protocols for quick direct routing. It's built for a cloud-native world, not for shoehorning through aging gateways. Suddenly, users are asking why a Teams meeting with a colleague across town feels like it's bouncing off the moon. The second routing mistake is a close relative, not allowing direct internet access for those critical Microsoft endpoints. On paper, blocking outbound connections unless they pass through corporate inspection makes sense. Security teams sleep better, knowing every request is logged, even if it's just PowerPoint phoning home. But M365 doesn't play well with middlemen that don't speak its language. You end up with unpredictable delays, broken authentication handshakes, or the classic "your connection is not secure" error that sends users running to unplug their Ethernet cables. Microsoft even publishes a living list of endpoints that should bypass security inspection entirely. They have their own layers of defense and require that split traffic to hit performance targets. Ignore this and you hear about it every time someone's SharePoint library takes forever to load or Exchange Online times out mid-search. Now, for the VPN misadventure, routing all Microsoft 365 traffic down the same slow, encrypted tunnels you use for sensitive apps like SAP or Oracle isn't keeping you safer, it's just piling on headaches. In theory, all your traffic comes from the office, so conditional access matches up and legacy network controls stay relevant. But most VPN concentrators weren't designed for constant cloud back and forth, especially not the multimedia payload from Teams or the file churn of OneDrive. If all of your branch offices and remote workers are forced to hairpin their traffic, sending it from their laptop back to HQ, then to Microsoft, and all the way back again, the result is a slow march of jittery calls, choppy video, and chat messages that arrive out of order. It's the kind of network path that looks technically correct but feels objectively painful in real-world use. One example that's hard to ignore, a retail chain with dozens of locations, each with its own internet circuit, yet somebody in IT wanted all Teams and OneDrive data to look like it was always coming from headquarters. So every single Teams call, even ones between 2 cashiers in the same store, had to loop across the country and back just to cross the street. That bit of safety through centralization meant their video calls crawled, screen shares timed out, and managers gave up on anything more complicated than a chat. Users were convinced Microsoft 365 was allergic to Mondays. The reality, a simple split tunnel configuration, letting Teams and other trusted M365 endpoints bypass the slow lane, restored their performance overnight without touching a single app setting. This is where Microsoft's own documentation gets direct. Their advice is to enable direct Microsoft 365 connectivity at each office location with local egress of internet traffic. Split tunneling isn't a security compromise. Done properly, it means productivity apps get fast, reliable connections, while your true crown jewel systems stay behind the VPN. But here's what holds people back: the nervousness that direct egress opens new gaps, or that they lose visibility over what's happening on the wire. It's a classic risk versus reward standoff. What stands out looking through these repeated mistakes? Once you remove the bottleneck, by letting trusted Microsoft 365 flows avoid excessive scanning, zigzag routing, or deep inspection, performance jumps up sometimes dramatically. You get fewer support tickets, happier users, and none of the old trade-offs you thought were non-negotiable. Most of the time, this is an instant win. No M365 settings to tweak, no advanced troubleshooting, just basics done right. But here's the nagging question. How do you figure out which hurdle is dragging you down in the first place? Users just know their apps are slow. They don't tell you if it's the proxy, the firewall, or that old VPN appliance limping along in the server closets. So what's the trick to catching the real culprit before the next team's meltdown? Diagnosing the culprit is your security stack slowing you down. Ever had that moment where OneDrive syncs 100 files in no time, but a Teams call next door lags and drops? That's the flavor of confusion a modern security stack can serve up, especially as organizations mix and match proxies, firewalls, and VPNs. Everyone wants tight security. Inspect every packet, block threats at every turn. But in the real world, making every cloud app run through the same gauntlet rarely leads to either top-notch security or happy end users. The idea that locking down every bit of traffic the exact same way will protect everything and keep it running smooth is one of those comforting myths that doesn't survive close scrutiny. Let's look at how the different chunks of your security stack play favorites when it comes to M365. Say you have a proxy that forces all traffic through SSL inspection. For Exchange and SharePoint, sometimes things limp along, but then Teams turns into a slideshow the second someone shares a screen. Why? Teams and other real-time services push a lot of traffic types, UDP for media, different protocols for chat and files, and most proxies just aren't built to handle that level of complexity on the fly. When everything gets decrypted, inspected, and pieced back together, latency finds its way in and the wheels come off. Some tools handle bulky uploads well, but choke on persistent connections. Others give a pass to low-priority endpoints, but hammer the critical ones that make calls and meetings work. It gets even more interesting when firewalls get into the mix. Modern firewalls love deep packet inspection. That's great, right up until they try to parse Microsoft's constantly updated list of service URLs and IPs. They're built for stable on-prem environments and get nervous whenever Microsoft decides to add a new CDN or change an API domain. Suddenly, random Teams workloads grind to a halt while OneDrive chatters away happily in the background because its sync traffic slipped through an open port the firewall still recognizes. Everybody in the building starts speculating about why OneDrive just works while SharePoint feels like dial-up. Sound familiar? VPNs have their quirks too. Routing all remote users through the same secure tunnel sounds like good hygiene, but it can amplify small bottlenecks. For users at home, all that encrypted traffic makes a round trip just to pick up a shared file or join a meeting. If the VPN concentrator isn't sized for live video and collaboration, the whole experience drags. Now, you've handed users something worse than slow internet. You've given them inconsistent results where one workload is reliable and another one sputters. This is the paradox no one really talks about. Aiming for maximum coverage can actually create weird patchwork problems that drain productivity. Your proxy, firewall, or VPN doesn't treat every M365 service the same, which means support tickets show up with notes like SharePoint lag but email fine, or Teams chat instant but calling dropped me twice. Most admins assume Microsoft is to blame or that something changed in the client. But really, your own security stack is picking winners and losers without telling you. Let's get specific. SSL inspection, intended as a line of defense, can unexpectedly strip away headers, break persistent connections for Teams or Exchange, and even derail authentication tokens. Even a minor delay in decrypting and re-encrypting can throw off real-time voice or video. Microsoft is well aware of this, which is why they maintain a living, sometimes massive, list of endpoints that are meant to be left alone. These aren't vanity URLs. Teams media flows, SharePoint uploads, Exchange syncs, they all have addresses Microsoft once bypassed. From deep inspection, ignore this list and plan on a steady stream of "is the internet broken?" complaints. Now, how do you actually catch the troublemaker? Real-world network monitoring pays off here. Microsoft offers a free connectivity analyzer, which checks from a client's perspective and highlights any detours or delays hitting their endpoints. Pull the logs from your own tools, packet sniffers, flow analyzers, or just plain event logs on your proxy. If you see big lags on TCP handshakes or repeated dropped packets for Teams calls, you've likely pinned it down. The trick is to go service by service and see who's getting stuck where. Find that SharePoint feels fine but Teams stumbles. The odds are your stack's treating them differently, possibly due to some catch-all inspection rule that nobody's questioned in ages. Here's a true story that hits close to home. I worked with a company that recently upgraded their security stack, proud of their new proxy with advanced threat detection. About 2 weeks in, the complaints started. Teams went from tolerable to nearly unusable, but SharePoint was still zipping along. It turned out the proxy was flagging real-time UDP traffic as anomaly, something the team never thought to exclude. Flipping the right bypass for Teams media traffic brought calls back to normal in less than an hour. No new licenses, no escalations to Microsoft, just a missed detail in the proxy config. So what's the fix that doesn't throw your security posture out the window? It's all about maintaining a fresh, well-managed bypass list and applying split tunneling for those services that demand low latency and consistency. Microsoft even publishes the precise addresses to trust. When your inspection stack and routing rules match what M365 expects, things settle into a groove. You keep phishing threats and risky domains under watch, but your core productivity apps move at the speed users expect. Of course, if the idea of opening up direct paths or split tunnels gives you pause, there's still more to consider, like bandwidth planning, traffic prioritization, and convincing the business it's worth the change. And that's where things can get even more interesting. Proving the case, selling network changes to leadership. You've found the network quirks and you know what's slowing down M365, but reality check, getting your higher-ups to buy in is a different animal. Most organizations aren't keen to tinker with their carefully layered security controls unless there's proof that the effort is worth it. Suggest a new switch or firewall rule and someone's bound to ask, how do we know this won't just cause other problems? The default stance is caution, especially from leadership that hears network change and imagines downtime, audit headaches, or extra risk. That's fair. Their job is to weigh the balance between keeping the lights on and not accidentally letting something slip past the gates. The sticking point almost always circles back to data. Leadership wants more than gut instincts, no matter how much noise is coming from the help desk. Maybe they'll listen to stories of users complaining, but they definitely perk up when you start showing numbers. So the question is, how do you get those numbers and what makes them compelling? Here's where a little homework goes a long way. You run baseline tests before any changes, measure current latency for Teams calls, record SharePoint upload times, and note how long OneDrive syncs actually take. Then you tweak the routing, bypass the proxy for just the core Microsoft 365 endpoints, set up split tunneling for Teams, repeat the measurements after. The differences aren't usually subtle either. In a side-by-side comparison, Teams call setup drops from 7 seconds to under 2. SharePoint files that used to crawl now show up in half the time, and those random connection drops start to vanish. You can plot that on a line graph or put it as plain old averages. Either way, it's the kind of before and after that translates into something boardrooms understand. Let's talk specifics because numbers make or break this conversation. Teams calls, for instance, work best when latency stays below 100 bims. File syncs on OneDrive get painful when upload speed drops below 5 megabits per second per user. Microsoft doesn't always spell out the minimums for everything, so this is where your own metrics fill the gap. If you have a remote branch that hairpins all traffic to HQ, it's not hard to see latency hit 100 ms or even 200 ms at busy times. Suddenly, half the complaints make sense. A regional office routes SharePoint through an overloaded proxy for inspection. The upload speed looks fine in the test, but real user experience lags, especially when those inspection engines get bogged down at peak hours. Now, you could stop at just user anecdotes, but putting real bandwidth requirements in front of the decision makers helps draw a line between what users feel and what's happening under the hood. If you can say Teams needs 1.5 Mbps per meeting participant just for audio and video, and then show that users routinely get half that because they're stuck in a security queue, it's not about wishful thinking. It's about technical reality. Show the gap between the cloud-ready path and the bottlenecked one, and questions about why do we need to invest start to fade. Even better, map support tickets or help desk volume to the performance metrics. We saw a 30% drop in Teams complaints the week after we updated our routing, and the pattern tells itself. It helps to reference results from peer companies and real-world case studies too. Healthcare orgs, for instance, often have strict controls, but many have proven that adopting Microsoft's guidance for direct local egress didn't compromise their security posture. Instead, they reported smoother Teams meetings and less downtime in SharePoint. One manufacturing company tracked everything. Before the change, daily Teams outages averaged 10 minutes of lost productivity per user, not to mention the time spent troubleshooting. After fixing their network routing, not only did complaints plunge, there was a measurable uptick in project velocity, simply because collaborating didn't grind to a halt every time a firewall hiccuped. The bigger picture is this. When you translate network tuning into measurable business outcomes, reduced downtime, fewer support tickets, and time saved across the board, you turn a nice-to-have tuning request into a cost avoidance or even a productivity booster. The return on investment comes out of overhead costs shrinking. That means fewer emergency IT escalations and more time spent on innovation instead of firefighting. The case isn't just technical, it's practical, economic, and user-centric. If you show leadership that your changes pay off in the form of happy, productive employees and a support staff that spends less time on the phone, you've got the foundation of a strong argument. Most executives love hearing that network investments aren't just padding the infrastructure, they're actually buying peace of mind and making collaboration tools truly usable. With the right charts and a few well-chosen anecdotes from your own data, you can usually move the conversation from why change anything to how soon can we make this work. Once leadership sees that network investments can quiet down help desk tickets and push projects forward, you're not fighting an uphill battle. Instead, you're giving your organization a tangible way to get more value from the hundreds of thousands they're already spending on Microsoft 365. And when you finally shift the focus from endless app troubleshooting to rooting out network snags, users notice too. So if you're tired of the blame game and want to shift your M365 performance from pain point to bragging right, there's a simple next step. Let's get into what you can actually control and start putting those network fixes to work. We've all sat through Teams calls where you'd swear the audio is traveling back in time. The bottleneck isn't in some Microsoft data center. Most of the time, it's the switch, cable, or firewall sitting under your nose. If you really want smoother M365 performance, don't keep blaming the cloud. Map your own network, see old patterns for what they are, and rethink if that gateway still earns its keep. There's always a reason for slowdowns, and more often than not, it's a piece of your own puzzle. For more real-world M365 advice, hit subscribe and get the upper hand.